Hello, hello. Welcome back to this tutorials. We'll continue our long journey, and very detailed journey, actually, to our interaction with terrain. From really quick summarize from the last tutorial, we was able to walk in actually just one terrain. We create really quick nav mesh agents to go from random from one target to another target, which one is indicated with this blue spheres. But we saw in the last video, we saw an issue where if we have many of them, we actually the trail, or as we can say, our request pool is getting larger than we can actually execute. And all the steps, even though it's still executing, the length of the trail getting apart from an object itself. So what we're doing today is in this tutorials, we actually allow the object. We'll work only with one, but we need to indicate on which terrain the object is standing on. In our case, we have seven by seven. So if I go like this, nope, doesn't work. Yeah, that's the one. So we have 7 by 7 terrains. This is a good approach for games, especially when you don't know how large your map must be. So creating like terrains by 100 by 100 meters in this open world, not open world, but in this like game, it allows me to anytime to add or remove, make it smaller. And then another goal is as well to using this approach is actually if you have like a tile, which one is a lake, and you can actually random insert and replace any certain terrain square with the lake. So this allows when the game starts for the player, it allows like how to say the players will not know where the lake is, so it still will be like a bit search and explore your world around you. Okay, so to start with, first of all, yes. So, to quick note, to work with this one, all terrains. Oh yeah, I need to take this one out somewhere. Go here, please. So to work this one, the script is added to terrain parent. It's called terrain painter, and we have 49 squares, 7 by 7. So we have 49 squares. I hope it's 49. 7 by 7? Yes, 49. So we have 49 squares. And as I mentioned before, they could be added or expanded to a certain direction. What I had done before I started this video, actually, I mixed them. I mixed a bit order of them. So if you can see from here, if I go, it's going up, then it's going left, then it's going down, and it's going mid area, then it's go outside, and so on. So the order in terrains here is mixed, and I done this one on purpose because I wanted to make a robust code which one actually puts everything in order. Then we create the array. This will be, I'll discuss about this one more in when we approach the code. Another thing is what else? Coordination system is very important. Using by 100. So remember, if your number is different, and squares is different, let's say 150 or 200, etc. You'll face two things. Going more than 100, you will working with the larger alpha maps that could potentially decrease your performance. And another thing is, if you increase your alpha map but decrease the quality, which we're now will covering in a few lessons in the front as well, how we can actually decrease the number of pixels we want to draw and what is the downside of this one. So yes, if you decrease the alpha map resolution, you just will start seeing like pixels, like squares of interaction on the map. So you don't want to see this one. You don't want to have people walking, I don't know, in the middle of a grass area field, and it leaves like squares, like a chessboard. So 100, I found like a goal point for testings I done. It could be even smaller, but I don't want it to complicate too much. I haven't tried smaller. I had tried only larger numbers. Okay, so all the one more time. All the terrains must be a child's under the parent, which holds terrain painter script. So, and here we have even left a note from last time. How to we left the note for ourselves, and do not forget what to do. So one of the things is we need to well, we can delete this one. So we need a private. We go for terrain, and when I want to create a double 2D array and call terrain. I think it's terrains. One of the key points what I'm doing now is I'm not defining the size of terrains. I'll leave it to this one later. Okay. What else I should do? Oh yeah, that's a good one. We will do the math calculation for how many terrains. How large and big? It's not large and big. How to say? What size of 2D array we need to create? So to do that one, we will create private int terrain array counter. Yeah. Okay. So why we need this counter? All this we will do here. So let's talk about this one. So let's go back to our trustful painter. This might be not case in this might be not a case for you. How to say, it might be not working for you, because if your map is not square, my approach, you need a different approach. But let's put it this way. So because I'm using a square, the number of members to find how much of Y members and X members, or in other words, how many we have in Y direction, how many tiles we have in Y and how many in X, is really simple. The total, you need to take square root. So if it's 1 tile, square root is 1. If it's 4 tiles, it will be Y on 2 and X on 2. If it's map which one has 9 tiles, so it will be square root, it will be Y 3 and X will be 3 as well. So that's formula I'm using to calculate how many squares we have on Y and X, the axis this way. Okay, to do that one, we need to array counter is equal to, I know the number what we get back will be float, because we'll be using a math.f, mathf. So what I do is I will cast. You know, guys, what I will do, first of all, I'll do function. I will explain casting later. So, or maybe not. Maybe it's easier now. So, whatever we get here, let's put it this way. I put answer. Yes. So wherever we calculate in this brackets, if we put another brackets in the front, and we describe what format we want. Let's say I want integer. So if we calculate here double, if we calculate here, I don't know, float, which one will in our case will be float, it will be casted in integer. So the brackets with the format will cast whatever we get in the front into that format. Okay, the compiler will try to cast into that format. Sometimes you can't. Let's say you can't game object to cast of integer because that's not even related, familiar as how to say data formats. So as I mentioned before, we use math.f, and it has really nice square root, SQRT. And in the brackets, we need to give what we want to square root from. So as I mentioned it, all the terrains must be child of the parent, which one holds this script. So we're saying this script game object. So to what game object is attached? Dot transform, and transform has a child count. This is a number of how many childs is attached to this game object. In our case, is 49. So square root of that one is 7, but the square root returns float, even though we really relying on that number. It doesn't work for you if you have 49 but yours is like something like that. It's I don't know even in English how you call this one. I know square or rectangle. That's one. Yes. Okay. So we find how many x and y we need. For good measure, to be precise, let's print that one in our console. Terrain is made of size array counter So in my case, it should to print terrain is made size of 7x7. That is what I'm expecting. Okay, 7 by 7. In your case, you need to check this one. You can actually print your child count if you want here somewhere. I think it would be nice. Something like total tiles found. I just copy. Oh, sorry. Okay. So this should print 7 by 7 of 49. So that's really you can actually observe in this information to make sure it's everything works in the way you want. Now, when we know how many we have x and y, we can actually define our terrains is equal to new terrain And now we know how big it is. It's the array counter, the array counter. So now we just defined the size of the 2D array. So it will be 7 by 7, and we can address each of the tiles by the indexes. So 0 and 0 will be first, and the 7 0 it will be 1 2 3 4 5 6 7 somewhere here, and 0 will be here. But if we have, like, let's say 2 3, so it's going 1 2 1 2 0 1, sorry, 0 0 1 2, so here, and 0 1 2 3, this one. So 2 3 is this one. You get the idea. Okay. After this, now we can actually read all the child's child index is equal 0 as long as child index is less than transform dot child count and child index plus plus. So we'll loop from one to another child in our all hierarchy, and we check what the goal is. Let's say the first member is this one. That's easy peasy. And the second member in the hierarchy is this one. So how we know in our 2D array, which one are we building now, the second member, which ID of X and Y we need? That's really simple. We can look where in the map it is, because our X, the first square will finish at 100, and the second finish at 200, and so on and so on. So it's really simple to find this one. It's 200 because his pivot point is here. So it will be 200, and it will be 200. Really simple. So X and Y, it will be 2 and 2. To do that one, we need to find end X, and we need to find end Y as well. So that's, well, first of all, array is only ints. Even though our math will return only ints, sometimes might be some decimal points, but we want to make sure it's int. So what we do, we'll repeat again what I've just mentioned about casting. So we'll cast anything what we get here into integer, and we will get this one, transform dot get child. We pass child index. So the first member, the second member in a hierarchy, third members in a hierarchy, we go from one to another one. So we say transform dot position dot x. So we find your position, but as you can see, we need number 2, not 200. That's really simple to do. Divide by 100 f, and that's it. That's how you find your how to say ID in which place in an array you need to insert this child. Okay, for int y we need to use z because it's 3-dimensional, and the forward is, we're looking here, y is up, but then you flip this one down on the floor, y is still up, but z is forward. So we're looking like this. So this is X, and this has become Z. Oh, sorry, Z. And the person is standing here. Cool. Okay, so that's why we're using position Z and this Y. Next, what next? We want to do some, well, it's really simple. We need to do some, how do I say? We need to make sure we're not doing some stupid things or something like this. We need to make sure we're not going outside of boundaries. That's one. If X is less than 0 or Y is less than 0 or X is greater or equal to array count, array, how do you say? Oh, sorry. The array counter, or Y is greater than or equal to the array counter. What do we want to do? Well, I think first of all, yeah, of course, we need to debug and .log error. It's an error, and we were saying that the rain painter child count mistake. And it's really simple. One good thing in Unity is when you get an error message, you double click in Unity on it, and it will open your script, the location where this error was hit. So it really helps you to navigate the source of error. And this is, I think, the first time I'm introducing you. If I can spell it, continue. So on line 31, we have a for loop. A for loop will be executed until child x reach no more than child count. In our case, 49 times for each child assigned to the parent in a hierarchy. Continue mean that if we hit an error of calculations, let's say we hit on a number 12, continue mean stop this loop and jump to the next one. So in our case would be, if we hit the error on member number 12, stop here and go to number 13. If the number 13 is still error, stop here and go number 14. Don't execute the rest of the code. And the rest of the code is, we actually want to add to array. So terrains, that's one. Terrains at x and y, which we just calculated, is equal to transform dot get child at child index. Dot game object. Yeah, that's one. Oh, game object dot get component. We want a component attached to that game object. So in this scenario, yeah. So that means even though the second member is on 2 and 2, we find it. If the third member is again here, we calculate and we keep inserting them. It can end up that you will leave some empty gaps in hierarchy, but every empty gap will should print one of these errors on the line 36. And of course, you should stop the game and investigate what is happening. And the most I think the first thing what you need to check is your square root answer. If you're not using square, this approach might be not working for you. it's not really hard to adjust. You need to array counter for x and y, and you need to do this calculation twice for how many you have in x and how many you have in y. Okay. Yeah. Another thing is what my advice would be, if you're still getting some errors, try to look your position in the world. Don't forget, we're not using a local positions, transform.local position. You can use that one if you want. I'm using a world position, so because how to say, terrain file, which one has the script attached, is at 000 location. That is my that's my world's. That's my world 0, and all the child's all terrain squares is attached, is related to that one. If your terrain is somewhere else, let's say, I don't know, pushed somewhere, you might want to use your transform.local position, whatever, which one is more suited to you. A few more bits. Yeah, this is a good one. If terrains at x and y is equal to null, we want to debug .log error. And the error is terrain child does not have terrain component attached to it. So what I was sorry, I got a phone call. So we're checking if every child in the terrains has a component terrain. If we added any member to the list, sorry, we have not added anything because it does not have component terrain. We're checking here if it's null. We want to notify in our in our console. Let me think. Yeah, that's it. Okay, cool. That's it for a start. So in this point, we just made a list. Let's have a look. Environment, terrains. We made a list and we sort them all in 2D array in order which can match all coordinations. So we can actually rely on position when we giving the request to interact with terrain. So to do that one, we of course we need to change our terrain request. 1 second. Terrain request. Terrain painter interactor. Okay. Oh yeah. So I have already written and it's here. So let's delete this. No. Let's delete this. So we need to add a new public variable, which one will hold terrain ID. Terrain ID will be exactly this two IDs, X and Y, and they should be integer. So we'll be using a vector to int, and we call terrain ID. So each time we add a new terrain request into our bucket, to our list, we add the number of terrain ID. So this is a point where we increase our we will increase our performance, because we can actually change, how to say, we can actually change how we interact with all requests. We can actually merge free NPC. If a free NPC is on the same tile, we can actually merge them into one request, get alpha map, change alpha map for free for whatever n number of NPCs on that tile asking to interact with terrain. We can merge all this request into one and make a change at that frame. So previously we had up to 10 NPCs, and we can see, oh, that's too many requests, and taking time each time for number one terrain request. We're taking alpha map, we're changing, we update terrain map, and we're doing every frame this one. But when the frame rate is drops, we can only handle a certain amount of terrain requests. Then we add terrain ID before we actually, before we taking all requests, execute all requests, we can actually look for the same ID, so we can actually merge all requests into one. Okay. Another thing what I change as well is we need to add this one, vector to int terrain ID with underscore. So this is I think tutorial 1. It's a constructor. So we're adding one more, and here is another line which one you need to do. It's to say that that variable into this class. Okay. After we've done this, we need to change here. So we're getting terrain paint request, and we have position. And here we have error saying that, well, you're missing one more variable into your constructor. So yes, we know that. We know that because we just added vector ID. So let's calculate here integer x and integer y. So we know it should be int. We cast into integer, and we do really simple thing. We do taking position where we asking for request at x, and we divide by 100. That's it. That's our x. Same we need to repeat for y. We cast into integer, and it's position dot z. Don't put y. I made so many times mistake by putting y. It must be z. And we have x and y just calculated. Another thing is, I want to make sure that this request ID is not outside of our terrains. Let's say for some reason NPC went on another terrain outside of our main map. In other simple words, putting the player or NPC walks outside of our map for X or Y reason, and it's keep pushing request. It's keep pushing request to interact with terrains in our array, but we have only the 49 terrains which one we allow to interact with. So we need to foolproof here. So if X for some reason is less than 0, or less than 0, or y is less than 0, or x is greater and equal to terrain array counter, or y is greater or equal to terrain array counter, we want debug error. Terrain painter. Hope so, guys, you can see. And should I even make a bit larger? Yeah, let's make it a bit larger. Terrain painter request is outside of main map. And we do return. Different from continuous, it's not breaks the loop. Return will go breaks in this place the function. So when this function is called, and then if for any reason we hit the line where it's return, it will stop executing this function and gets back where it was called. But if we succeed and x and y is not less than 0 and not greater than terrain counter, we want to say, okay, we need to another member here. And another member is new vector to int, which one is x and y. So we just, from receiving from terrain painter request with position, we made a calculation about what ID should be on terrain and the object is standing. Okay, few more steps left. Actually, 3 more steps. Step number 5. Yeah, we can. Okay. Step number 5 was a step which one I done for actually debugging. So I wanted to show you guys and share this one. So before we execute, so debug.log, it might be very useful for you. So our dude is standing on terrain tile with index off. And we want to add terrain request queue, the first member we're trying to execute now, and terrain ID. That's it. So we'll get X and Y. So we can actually print every single time we're walking around. This is a good for debugging if you're facing any errors or anything. I'll leave it a comment out now because this actually loads quite a lot of data into our console. Okay, step number 6. Yes, step number 6. We won't be using anymore the one terrain, which one we dragged in, the terrain which one we was using up to this point. So we won't be using this anymore. By deleting this, it will give quite a many errors here. But what we need to do is what we need to do here is, let's have a look in the notes. Yes, first of all, let's change conversion. Okay, so this function takes vector 3 per position, but instead of that one, I want to take the function which one converts position to alpha map. I want to take not position, but I want to take terrain request TPR. And TPR we need to change into this position will be terrain painter request dot position. So we know where is position. Now we need to take terrains, and we need to X and Y ID, and that will be TPR dot terrain ID dot X, comma terrain painter request dot terrain ID dot Y. So this X and Y will return from all the list that tile on which our dude is standing on, and minus his position will get terrain position. We talked about this one previous tutorials. So only now what's left is actually to copy this one, copy, and replace all this terrains. Oh, okay. Now what we have here, paint request. Okay, now instead of passing vector 3, we need to pass the TPR, the terrain request painter, and we just doing by this one. Next is a tricky part. A tricky part because how to say? First of all, we can replace here with yes terrains and X and Y. So instead of terrain, we just pass this one, and same applies here. That's it. But we'll face some error here, and let me explain a bit. The problem is, let's imagine this is our square, or let's draw it's our one tile, and X is our NPC walking, and his interaction is like this, and a fade zone is a bit bigger, or wherever you want to set it. The problem is when we will be approaching the edge. When we approach the edge and our NPC dude is standing close to it, a request for alpha map will be outside of the image of terrain data it can actually produce. So what we need to do is to make sure we're not requesting any pixel of alpha map outside its boundaries. And another thing is, don't forget, the requesting terrain painter is in pixels, so we have like a small square. Its pivot point is this corner. We know we have our offset of a person to match. The person is in the middle, and terrain request is offsetted. But still, the pivot point we're requesting for all the pixels we want to interact is the bottom left corner. Taking this in account, we just need to make sure we just need actually to foolproof this one, and this will be a long one. So grab a drink and let's go. So let's start with the easiest ones. A map position, which one we using as request. .x if it's less than 0, or a map position dot y is less than 0, or let's say a long one, a map position dot x is greater. Sorry, no, a map position. So if you're going back here, if this request, can I actually select somehow? Yeah, I can. If this request going close to this edge, X, the request is still in this corner, but we need to calculate this edge. So we need to know how many pixels forward we need to calculate. So it's terrain plus terrain painter request dot paint size plus brackets terrain painter request fade size multiplied by 2. Why by 2? I was covered this one last lesson, but literally you have fade zone in both sides, on both sides, and you can actually see here because we're requesting 2 sides. So if this is greater than the terrains at, well, just paste terrains at x and y dot terrain data, and we want with alpha map. Come on, cat. Terrain alpha map width, if it's greater, or we need to literally repeat the same. Few changes. Okay, so alpha map y is greater than terrains, not width, but sorry, alpha map height. If this is the case, if this is a true, we want to execute something. And execution is, first of all, we want to debug. Terrain paint request is outside of alpha map boundaries. I hope so. It's spelled correct. And we will use already a known command return. So we want to stop paint request function at this point. If we hit this line, we don't want it to do anything else. Okay, and you won't believe it. That's it for today. I think so. Let's have a look. Let's do Control-Shift-B for compiling. Everything compiles, no problem. Why are you using Control-Shift-B? If I haven't mentioned before, Control-Shift only saves this file, and if you have many more scripts open at the same time, you want to save all of them, it's Control-Shift-B. And sometimes if you change here, but error happens somewhere else where you call that function, somewhere another script which one you have closed now, because let's say we change this terrain, we change this one, how to say, terrain request constructor, that's one. And it's have two reference, and I can actually see where two reference they are, but it could be many more requests, and it will be in the future. So by changing this one, I no need to actually go every single script and found all the errors it caused. It just Control-Shift-B, it builds, it will check all the scripts. Well, it will check all your project, and if it finds any issue, it will happen here, and just double click and it will open that script. So after we save, okay, I have paused to make sure I'm recording. So let's have a look. Yay. I will do this was painting as it was. And here is the line to go another one. And it just jumped to another one. It's not interacting with the grass yet. But if someone already noticed it, you have a good eye. You can notice here the line. This is a line where it's like a blind spot for this interactions. And what we want to do is actually it will be for another lesson, but what we need to do is actually to calculate. When we have a half square off, we would still want to paint a half, and possible, not possible, how to say, willingly, not willingly. It's a demand to do that one. It's hard to do, but it's really possible. So when you have a request like this, and a half of request is another tile, you need to grab another tile and maybe pass this request. Or it might be really simple. For performance, it might be when you going outside, you painting only this side, but then you hit another side, you start painting this side, and visually it looks like a line going from one tile to another tile, even though we stop on a half. But because it's so small pixels, we no need. I'm trying to avoid to run two requests on two different alpha maps at the same frame. I how to say, sacrifice a bit quality by just drawing half, and when it hits another side, you draw another half, and it still looks like a one line. Cool, that's all for today. Thanks for watching. I'm trying to keep it as short as I can. Okay, thank you and see you soon. And